5G Program Manager at Keysight Technologies. I think many of you in the audience are either working with or highly interested in 5G. Roger's talk, 5G Test and Measurement Technologies for Network Equipment Manufacturers, Chipsets, and Devices, aims to survey the major market trends and challenges ahead and gives an overview of test and measurement solutions for 5G. Roger has been directing Keysight's 5G program since 2014. With 34 years of engineering and management experience in wireless test and measurement, he has worked in programs starting with analog cellular radio, evolving to 5G, and on every standard in between. Please welcome Roger Nichols to the keynote stage.
Thank you, Janine. How's the sound? Is it okay? So it's a pleasure and an honor to be here. I have not been to Beijing for a few years, so it's great to be back. It's also an honor to share a stage with Steve and Alexander, my colleagues in the test and measurement world, because really that's what it's all about. You have to be able to measure what you're doing to know if it turned out the way you expected. So in the words of William Shakespeare, please lend me your ears for maybe 25 minutes, but I will start with some audience participation. So when I started working on 5G in 2014, I was the only person at Keysight or Agilent at that time that was working on 5G full time. And so I want to know, in this room, how many are working on 5G? Let's not be shy here. Okay, maybe 50% of you are working on 5G. How many of you are managers, managing people working on 5G? Yeah, there's a few. So do you have enough resources to get the job done? There's an honest person shaking his head right now. No, right? I have never met a project manager that said they had enough resources, enough people, enough capital. Okay, so there's a lot of challenges out there, but it turns out the industry doesn't have enough resources either. And there's a lot of technical challenges, and I will just describe one example. So in the boring FR1 space for 5G, the new bands at 3.5 to maybe as high as 4.9 and ultimately now up to 7.1 gigahertz. There is a significant challenge that I have heard about a lot recently, which is a very big difference in uplink and downlink performance that is maybe 16 to 19 dB. And this means that managing a link budget in both directions is very difficult. It also means that for 5G, in which the uplink data demand is growing and may end up being higher than the downlink data demand in some applications, this is a pretty big challenge. So that's a big thing to overcome. Just one little piece with all this brand new greenfield spectrum that we have that's going to take investment and other issues. Well, what if that was a harder problem? What if you had a 300 or 200 dB link budget issue you had to deal with? So I'm going to talk a little bit about that later on in the organization, or later on in the talk. But the point is that to overcome these challenges means innovation. And that starts with I, and that's what the I stands for in this conference, EDI CON, EDI CON. The I is about innovation. And we are all going to have to innovate to make 5G successful and make that work. So what is 5G trying to accomplish? Well, there's a few challenges we'd like to overcome. One is just the sheer demand of data on a global basis. So it is now over 20 exabytes per month that the world consumes in mobile data. This does not count the data that you use on your PC. This is mobile. 20 exabytes. That's a 21, in this case, with 18 zeros after it. So that's a big number. It's very hard to understand how big that number is. So I did a little thought experiment. It's 320 million 64 gigabyte thumb drives. And if you add all those together, line them up, it's 6,500 kilometers long. That's larger, I think, than the two farthest points from each other in this very large country of China. This is a lot of data that the world is going to have to figure out how to accommodate, and it's growing at anywhere from 40 to 60% per year. There's also power consumption issues. The demand we have on the power systems is growing for communications. The networks use about 1.5 to 2 kilowatt hours per gigabyte that is delivered to you so you can watch your videos or send your chat messages. This is about half of 1% of all of the power generated in the world. And for example, not all of it is on a grid. Some of this has to be generated locally with DC or with diesel generators. So India, for example, uses about 2 billion liters of fuel every year just to power their non-grid or bad grid base stations. So we have to also make this much more efficient, and at the same time we have to accommodate a larger demand with peak connection densities that are very high. I took this photograph a few years ago at the high-speed train station in Nanjing, only a few hundred kilometers from here, and that was at the ticket counter. And almost everybody in that room is checking their phone. And the number of megabytes per second that they are demanding is going up. And when they're all crowded in a room like that, they want their device to work. And making this work well in a cellular system is very difficult. This is a big challenge. And this slide does not cover the decreased latency requirements, the increased reliability requirements, the large flexibility of the system to handle many different kinds of connections, and the work that's going to yield these kinds of opportunities for us as an industry. You can look at these numbers and see how much money and how many opportunities and how many people will be affected by 5G over the next decade. I've been working on this for 5 years, and in another 5 years, we may have as many as 40% of all the global population at least in a place to be served by 5G systems. This growth right here is why we are in this room working on 5G. This is our business opportunity and our chance to change how society thinks and how we use mobile communications. And that's because it's not just you and me checking WeChat, watching videos about cats, or in my country, Facebook or YouTube or whatever. It's a growing set of industries that will use mobile communications that were not used by these industries before. Now everybody's heard about 5G and maybe remote surgery with low latency and high reliability, or how 5G will make autonomous cars or automated vehicles better. So we've all heard about that, and those things may come. That's going to take some time. But there's other industries that will use this as well that have maybe similar demands for capacity, for uplink and downlink speeds, like the finance industry. There's a lot of money in the finance industry. That's why they call it finance. So transactions, for example, is about $2 trillion a year, just transactions. So if they can put mobile communications that are more secure and faster and more reliable to work, then it will change the way society operates and generate even more opportunity for us. Also, gaming. It's a bit crazy that we spend all of this time on technology to enable things like Pokemon Go. But there's real money here, especially when you combine gaming with advertising. And so that's where the big opportunities are, and also the demands on the technology that are going to drive so much challenge. So what's happening around the world? I'll just talk about three general areas. A, the networks are being deployed. This is accelerating, it's moving pretty fast. B, the standards are maturing. We're making progress on standards, but as I described, we have a much more complex system that we have to accommodate now with the new demands that new industries have on 5G. So a little bit more detail. You can see the rollouts are coming. There have been announcements of commercial systems in 5G already. We have a couple of commercial systems up and running in the United States now with Verizon and AT&T. All three operators in South Korea are offering commercial services now in 5G. And there is one country in the world that has one slide, but look at the bottom row and you can see the various 3GPP releases that have come since release 14, moving now to release 15, which is going to be finalized again this summer. And I'm guessing that release 17 will be at about the end of 2021. They just started talking about that, so if I could extrapolate what I learned about what happened last week, I would say that's about right for release 17. But these continue to evolve, and they continue to get more complex. You can also see the announcements for commercialization that have happened. These are the ones I'm aware of, what I read about in the press reports. And also on this slide, you can see the growth to what Ericsson has stated as being 1 billion 5G NR connections in 2023. 1 billion connections. So that's a lot. If we added 1 connection per second starting today, that would take 31 years. So the connections will they will have to add these connections at a growing rate, the exponential rate as shown on the slide. And that means the standards have to be ready. And so this is the summary of 3GPP release 15, the overview, 90 pages. You can read that. Now you know what it's all about. That's a joke. Of course you cannot read that. But the point is, just the summary is 90 pages. The rest of the documentation is hundreds and hundreds of documents that describe a very complex standard for this new generation. And 3GPP is not the only standards body that is working on things that impact 5G. This is a sample of the different standards bodies associated with just the high-speed digital connections inside the phone, like the C-Fi and the D-Fi, and also the interconnections for display technology, USB, Thunderbolt, all those kinds of things. And this is part of what's driving the demand for more and more data. And I'm very excited that we are involved from a Keysight perspective in every one of these standards, as well as taking a big role in 3GPP, mostly to help the industry understand how to make measurements and the best and most efficient way to do that. So let's talk a little bit more about complexity. If you think about just the basic link between a base station and a phone, that's still a pretty complicated thing to test. And, but we've developed capabilities that will do the test of the components, the user equipment, the G node B, GNB, that's the term for the base station in 5G now. They have to come up with a new term every generation. And that is all a big part of our business, making measurements at the physical layer. But these systems have to be implemented in cities, on train systems, where the channel is complex, there's a lot of reflections, the uplink and downlink performance varies a lot. So now we have to make measurements on over-the-air systems, advanced MIMO systems. I think most carriers agree that the concept of massive MIMO is going to be necessary to overcome this 3.5 to 7 gigahertz issue with uplink, downlink problems. And so there's a lot going on there for MIMO test. as well as coverage testing and drive testing for all these new bands and new bandwidths. But the base station is connected to the rest of the network, the core and the rest of the RAN, and ultimately the transport network that transports the signals to other networks, other operators elsewhere around the world. So that can be tested beginning with UE emulation solutions that act like the user equipment and then help validate that the base station, the radio access network, and parts of the core are operating properly. But then the core needs testing to maintain and secure the network. Security is another big issue for 5G as we get much more users, as it gets used by industries that require higher levels of security. I don't care if my cat video is not secure, but your autonomous vehicle, your pacemaker, all of those things need to have very secure links. And so all of that needs testing as well. And then being able to test across the domain. Make sure you can associate things happening at the application layer with what's happening at the physical layer and everything in between. And to me, it's very exciting that we are involved in all of this now. I was delighted that we announced the acquisition of Ixia a few years ago, and that enables us to link all of these things together from the RF level all the way down, or all the way up, the RF and electronic level all the way up to the application level. And with capabilities with automation and cloud, and also data analytics that will help people understand a lot more about what's going on given the nature of what's happening. So that's all going to require innovation, and I'm going to just highlight a few examples that I've noted in the industry. These are all public information, and it's exciting for me. I stand up in front of you and I have to take the advantage to talk a little bit about my company and the excitement that we have of being part of these. So first of all, Qualcomm just demonstrated the capability of a low latency connection using one of their chips with a robot arm. So this is a kind of a big deal because making the mechanics of a robot arm and the feedback system work properly requires a very low latency connection where you have an instability problem. We've all seen demonstrations of this, and part of that is getting the modem to work properly. And we helped them with this. This was very exciting to see happen. And then they also just did their first FDD data call in 5G as well. So a lot of places in the world don't have the luxury of an FDD system, frequency domain duplex, separated two different frequencies, one for uplink and one for downlink. But a lot of them do, and so the systems have to be flexible to handle either one. And with a NSA, non-standalone FDD system, the complexities of intermodulation distortion and many other problems have to be overcome, and this is a difficult set of measurements to make. And then lastly, some work that we did with MediaTek for an LTE and 5G multi-mode data call, just recently announced. All these were visible at Mobile World Congress. And just watching these innovations happen is exciting for me, having seen almost nothing starting back 4 years ago. And then in devices, you can now buy a commercial millimeter wave user equipment from Motorola. Lenovo Motorola. This is actually, to me, very exciting because I said I did not think we would see 5G commercial millimeter wave as early as 2020, and yet it's available now. And to help people develop and showcase this stuff was a very exciting thing for me to see, and we demonstrated this at Mobile World Congress. Also, Samsung for a FR1 5G device just demonstrated a 256 QAM 4x4 MIMO link, which shows the highest theoretic possible data rate connection in that bandwidth, in that band, and we were part of that as well. Again, more innovation to show that we can actually make this stuff work. And then this last one is a little bit more complex. This is a network situation. Most of the network capability now is fixed, custom, high-performance hardware, and we're moving to centralized, virtualized systems, which is extending out into the radio access network. And so this is this CRAN concept, or a centralized RAN, and that means disaggregating the base station so that the remote radio, or the radio, is in a completely different location than the baseband. And the link between the baseband and the radio is what we call front haul. And that link is, right now, there's front haul systems, but it's a proprietary link. And there's work being done now to standardize those links so that it's a common interface for everybody to simplify the build out of the system. And this was a demonstration that was done at Mobile World Congress. And 5 companies got together: semiconductor, operator, FPGA, test equipment, antennas, to get a system where we demonstrated the new standardized link from the ORAN organization's standardization group that we are part of. And we were able to show this off at Mobile World Congress. And so 5G is not just radio systems, it's all of the things that have to happen in the network as well, and that adds to the complexity. And so, as I say, deployments are accelerating, the demand for systems is coming up, the standards are maturing, but we still have a ways to go, and things are very complex. And we've been involved for a long time around the world. The first version of this slide that I created had 3 companies on it. And that was a long time ago. And so I'm excited to see this grow. But this is what innovation takes. Innovation takes working with the leaders in the industry. And we work with most of you. We actually work with our competitors. Alexander knows this. We work together on the standards bodies because it makes sense to collaborate on that. But that's what innovation takes, is when you have the highly constrained problem and the unconstrained human mind, and working with the best and the smartest people in the industry. So let me come back to my original example. Let's talk about the Voyager spacecraft. This is the space probes that were launched in the 1970s, right around the same time. And Voyager 1, Voyager 2, they toured the solar system for a little while, toured the inner planets and the outer planets, and then they left the solar system, and they are now both outside of what we call the solar system, a long way away. In this case, around 20 billion kilometers away, and moving away from us at faster speeds. We can still communicate with these probes, and the power available on the space probes, as you see there, is 245 watts, and it loses about 4 or 5 watts per year because they use plutonium batteries that decay over time. And so at some point in time, they will stop their ability to function. But I was excited about this because about a year ago, they had to change one of these probes to adjust the thrusters that align the antenna to point the antenna back to Earth. And the fine-tune adjusters failed, and they had to change the coarse tune adjusters to fire at 1 millisecond intervals. And they reprogrammed the probe to do that, and it worked. And this is with people working today at something that's 20 billion kilometers away, and it's 40 years old. So the uplink is 16 bits per second, not quite 5G, right? And the downlink is maybe 1400 bits per second. That's today. So I read an article about the link budget they had to maintain, but the article was based only when they were at Neptune. So Neptune is a lot closer. It's only 4.7 billion kilometers, so that was 16 billion kilometers ago. And they were able to maintain 7,200 bits per second communication with these satellites. And they did that with a free space path loss of 304 dB. So that's innovation. How do you do this? You put the bright lines on this and you figure out how to manage. Now it does help that they have a 64-meter antenna here on Earth to receive that. But that's what this is about, and everybody in this room is an innovator. There's nothing different between you and the people at NASA that figured this out. And that's what the innovation is all about. And it's our job to help you measure the progress on this, and I'm excited to be part of that. And I'm glad that we don't have to overcome 304 dB. I'm also glad that we don't have a 20-hour latency between us and user equipment like they do with these Voyager spacecraft. So thank you very much, and I look forward to being part of the innovation and the rollout over the next 5 years.